Hello, boys and girls. Welcome to Science and Daily Life. I am Sir Zamin.
And I am Miss Freeman.
How are you today? As for myself and Miss Freeman, we are very happy to be here to deliver today's lesson. Before we go into today's lesson, can you recall what we would have done in our previous class? Yes, we would have looked at respiration. We would have identified features of respiratory surfaces, stated the benefits of the characteristic of respiratory surfaces. We would have also discussed surface area to volume ratio. And lastly, we would have described tissue respiration. Ms. Riemann will now introduce our topic for today.
Hello, boys and girls. Our topic today is soil. Today, we're also going to identify our objectives for today is to 1, we're going to talk about or define soil. 2, we're going to examine the soil profile. And 3, we're going to examine and identify the organic and inorganic components of soil. Now, boys and girls, we're saying the term soil. What do we mean by the term soil? Now, soil is that part of the Earth's crust which supports plant life. How is soil formed? Can you think about that, boys and girls? When we say about soil formation, what do we mean? Now, it is formed by the breaking down of rock by a very slow process called weathering. The crumbling of rock to very fine particles is brought about mainly by extreme heat, wind, and rain. It is important for us to know the type of soil we are using when we're doing planting or any crop production.
Okay, boys and girls. So what is soil made up of? I'm sure we would have seen the white sand of the Soesdijk-Linden Highway area, the reddish soil in Linden, a cement-like soil from some parts of the Rupununi, and the dark brownish gray muds from some parts of West Demerara. As you dig a deep hole in the ground, is the soil the same from the surface to the underlying rock? Have you ever seen a freshly dug pond, grave, or sandpit for charcoal burning? If you have traveled through the interior and have looked at a cliff, you have seen several layers.
That's right. Now, boys and girls, as Sir would have said, maybe you would have dug a nice little pond, or we go to our yard and we say we are playing with the earth and we try to dig a little hole in the ground. What do you notice? Is the type of soil that you're digging at the top or you're seeing at the top the same as what you're seeing in that hole? Simply what we're talking about, boys and girls, is that these layers are called the soil profile. The top dark layer is usually thin and is called the topsoil. Under the topsoil is the subsoil, consisting of gravel, stones, sand, and clay. The deep tap roots of larger plants grow downhill into that subsoil. Further down is what is called the rock.
Students, a careful examination of that soil profile. We will look at a video to show us that soil profile. Do enjoy.
Hi, my name is Niranjan and welcome to another episode of Champak's IQ, where we teach you simple science experiments with things you can find at home. Today we're going to look at what's under our feet. And no, I'm not talking about concrete. We're going to dig a little deeper and give you the dirt on soil. Soil is the main reason why human life is what it is today. If it wasn't for soil, we wouldn't have had sustainable agriculture and we'd still be nomadic hunter-gatherer tribes. But to find out what soil is made up of, we're going to need a few ingredients. Well, you're going to need soil. I've also got this clear bottle. Could be glass, could be plastic, that's your choice. And I filled it with a little bit of water. And I have this homemade funnel I made. The idea is to pour the soil into the funnel. And once you've successfully managed to make a huge mess, you take a bottle of water, cover the end and shake it. Once you set it down, you realize that the heavier particles, that sand and gravel, sink to the bottom almost immediately. Let it sit for a couple of hours. Actually, I'd suggest you wait a day because your patience will be totally rewarded, because this is what it looks like at the end of a day. What happens overnight is that your particles start settling down according to their size. So right at the bottom you've got really heavy particles, and right at the top you've got the super light ones. What are these layers? Now that's the really important part here. Right at the bottom you've got sand and gravel. Just above that you've got finer silt, and immediately above that you've got the superfine clay. What you see suspended at the top is humus, or an organic matter, and the color of the water is attributed to the minerals that are dissolved in it. Each and every component that you see has its own purpose to play. The humus right at the top is organic matter, which is what feeds the plant. Below that is clay. Clay has the ability to trap water. This keeps water molecules at the roots long enough for them to absorb them. Below that is silt, which is where all the important minerals are. And finally at the bottom you have sand and gravel, which helps drain the waters quickly so that the roots don't rot. This kind of soil which has all these parts is called loam. And based on the percentage of each individual component, they can be classified into sandy loam, into silty loam, or into clay loam. What we've got here is sandy loam. Try it out at home and tell me what the soil at your place is like. Leave them in the comments below. This episode was brought to you by Champak and One Network. Thank you so much for watching, and please subscribe.
Welcome back, boys and girls. I hope you enjoyed that video and you would have understood what it's meant by a soil profile. Here, we're going to show you the different parts of that soil profile explained in a diagram. Take a look. As you can see here, boys and girls, you have before shaking and after settling. Now, look at the part that says before shaking. You can see two components of that beaker of substances that we have in there, solution that we have there. You have one, water, and at the bottom, you can see the soil. Whereas at the other diagram that you're seeing, it has after settling. And we will start with what you have as humus, which is the organic matter or the leaves and little twigs that you see floating in the container. Then you will have the water and clay.
Following that, we have the silt, fine sand, and then the coarse sand. I'm sure the video would have enlightened you on how to create that soil profile. So I do encourage you to try it at home and see if you can identify the layers of the soil.
Good. Now, let us move on a little bit today with components of soil. And when we say the term components, boys and girls, what do you think we mean? What is soil made up of? And today we're going to dive right into the first aspect, which is called minerals. The minerals of soils are derived from the rocks from which soil is formed. Minerals are inorganic substances found in the sand, silt, and clay. These minerals are required for healthy growth of plants. For example, we have potassium, magnesium, and calcium.
In addition to soil component, we have humus. Humus is the organic part of the soil and is usually responsible for the dark color of soil. Humus is formed by the action of microorganisms. Humus is very important because it helps the soil to absorb water easily, and it also loosens up soil. Can you think of any other function of humus? Yes, humus gives the soil the ability to absorb and retain moisture. Such soils do not dry out and require significantly less irrigation. Humus provides a reservoir for the plant nutrients available in the soil for balanced plant growth.
Now, I know that was a mouthful, boys and girls, but what really is humus? Can you remember the little leaves that are on the ground, the little twigs that you see around, or the stick or the branch from the leaf? That is what we're considered to be humus. And I'm sure you have played with those things before. Now, the next component we're going to look at is called soil water. Boys and girls, can you believe soil has water inside of them? Without you even watering or throwing water on that soil, can you imagine or can you think of that the actual soil would have water in them? Yes, boys and girls. Soil water is found around the inorganic particles of soil. Soil water helps to dissolve the minerals so that plants can absorb them. Here is another activity for you. Let us dive right into that, boys and girls.
Okay, students. So Ms. Riman and myself will demonstrate to you or prove that water is actually present in soil. So just give us a second. Let's run and grab our lab coat. Be right back.
A few moments later.
Okay, boys and girls. So we are well clothed in our lab coat to prevent soil from destroying our really nice clothes.
Yes. Now let's dive right into that activity. What you'll see here is that we have a heat source, we have a beaker containing soil, and we have what is called our Petri dish to collect the water that is needed there. Take a look.
Okay, students, so I'm just going to formally tell you about the activity. In order to conduct this activity, you would need a beaker, a watch glass, tripod stand, a heat source, a container to heat the soil, of course, a sample of the soil as well. Now, what we did here, we have our Miss went downstairs just now and quickly scoop up some soil for me, which we place in our beaker. I'm using the Petri dish, so as you can see, water droplets will be formed if water is actually present in the soil. Another way in which we can determine if water is present in the soil is by weighing the soil. So when Miss would have got the sample of soil for me, if we would have weighed it, say perhaps it would get approximately 10 grams, and after heating it for like a couple minutes, and if we were to weigh it again, the weight will be less. And that's the proof that water would have added to the weight initially.
Yeah. Now here, boys and girls, take a look. You will see that we're getting, well, the heat is applied to that beaker there. And you will start to see little vapors of water or the steam coming up from that beaker.
Students, this may take a while, so we're going to leave it on the heat source. And by the end of the lesson, before we conclude, we're going to show you if water is actually present in the soil. So we will continue, okay? So this will be left on until the end of our lesson. So let's move on, students.
Now, students, there's a final component of soil that we need to talk about, and it is called soil organisms. Can you think of some soil organisms that are found in your yard or maybe your backyard or your surroundings? Have you ever dug a nice little hole in the ground and you notice some creepy crawly insects around you? Now, I want you to take 2 seconds or 2 minutes out of your time, and I want you to take a nice little pen and paper or pencil and paper and list at least 3 organisms you think would be in soil. boys and girls, some of these organisms are large, while others are very small. Some are so small that you cannot even see them with your bare eyes. You would need what is called a microscope. These are called microorganisms. Now, I know you would have listed some animals or organisms earlier. And if you would have listed some of these animals, for example, earthworm, centipede,
Yeah.
your beetle larva, an ant, a millipede, a spider, and even a wireworm, you are correct. And there's so many others you can list. Now, these are just some of the organisms that are found in soil. I urge you, boys and girls, take another look at your surrounding and name some animals or try to identify more animals that are found in the soil.
In addition to that, student, when you are in grade 9, we will talk even more about the advantages of these soil organisms. So for today, I just want you to identify what organisms are found within the soil. Now, let us direct our attention back to the experiment. As you can see here, the petri dish is foggy. What happens when I raise it? Look. It is liquid. Where is the water coming from?
We can simply say, boys and girls, water is indeed found in soil.
Yep, look at that. Where's the water coming from? See? So the water would have evaporated, and what the petri dish did was to keep back the steam from escaping, and it would have condensed. So it would have changed from that gas to the liquid state. So here it is, students. We would have concluded that water is present in soil.
Very well. Now, boys and girls, today we would have talked a little bit about soil. We define what is soil. We examine a soil profile, and we also talked about inorganic and organic components of soil. We also proved that water is actually found in soil. Now, do join us next time as we continue examining soil. I am Miss Freeman.
And I am Sir Zamin.
Bye-bye.